Hello, students. Good evening, all of you. Okay, YouTube as well as Zoom, I am live now. So we can start the class without wasting any time. Okay. So first of all, I'm launching the usual procedure, right? I'm launching the technical poll. Okay, I have launched a technical poll here. So you have to answer me. If there is any issue for my audio, then screen, visibility of the screen, and other things, technical issues, you can let me know. We will solve that and we will start the class. Okay. So I hope everything is perfectly okay. So I'm stopping the technical check. Okay, so we are studying about, so all the days I'm repeating the same thing, right? We are studying about which chapter? Because some students, right? So they will study the things, but they will forget about the name of the chapter itself. That's a big, great issue. So we are studying about organic chemistry, some basic principles and techniques. That is the name of the chapter in NCERT. Okay, so if everything is fine, let us start. So in the last class, what we have studied about electrophiles, we have studied about nucleophiles and different types of reactions in organic chemistry. Which are the different types of reactions? One is addition reaction, elimination reaction, substitution reaction. In substitution reaction, we have studied free radical substitution, then a nucleophilic substitution, electrophilic substitution. So we have understood the basics of all this reaction, right? Okay, JNV Varda students, welcome to the class. Okay, then okay, JNVP, I think Palakkad, JNVP. Okay, great. So we have studied all these things, right? Then we have studied inductive effect. We have studied resonance. We have studied hyperconjugation. What are the applications of this electronic displacement effect? In the last class, we have also studied electromeric effect. It is a temporary effect. Why? In the presence of an attacking reagent only, there is shift of pi electron. That is why it is known as a temporary effect. What about inductive, hyperconjugation, resonance? They are permanent effect. No need of an attacking reagent. So that is a reason for that. So today, so we are going to study about one more thing that is known as aromaticity. So in the last class itself, I have mentioned this aromaticity. So today I will explain what is this aromaticity. Okay, what is the use of that? Okay, so what are the applications of this aromaticity? So we have studied inductive hyperconjugation resonance, and we know how to check the stability based on these electronic displacement effect. So if I write the order, okay, if I write the order of different effects. So first I have our inductive effect. First I have inductive effect. Second, hyperconjugation. Third one is resonance. Last one is aromaticity. So to explain the stability of an organic compound, this aromaticity has dominant role. Okay. So based on aromaticity, if a compound, organic compound is aromatic, then we can say it is very stable. Then no need to consider resonance, hyperconjugation, inductive. Okay. In one molecule, there is inductive and hyperconjugation. So we have to go for hyperconjugation, that is more dominant. If one compound has inductive, hyperconjugation, resonance, then you have to check the resonance first. Okay, resonance and aromaticity. Aromaticity, that is more dominant. Okay, aromaticity. So what is this aromaticity? So we have to check that, right? So maybe you might have seen this circus. So last 1 month or 2 months back, I went to Mysore. There was a circus happening there. After 12 years, I watched a circus. Okay. So in circus, you might have seen this bike riders, right? Bikers. They will be moving throughout this globe. Okay. This round surface, something. Okay. So similarly, in the case of a benzene, there are pi electrons present. So these pi electrons are also moving like that throughout the entire ring. So aromaticity is a stabilizing effect in a cyclic compounds. In cyclic compounds, cyclic, that is closed chain. Then due to why it is happening? Due to complete delocalization of pi electron. Only pi electrons are involved. Don't know. So some students will say sigma, not sigma. Pi electrons are moving throughout the entire ring. So that is known as delocalization. It is like you. They won't stay at a single place. They will be roaming around. Okay. So that is known as aromaticity, right? So in benzene, we have studied, here we have pi bond, then sigma bond, then again pi bond. There is conjugation, pi, sigma, pi conjugation present. Then in chemical bonding, we have studied if PZ is an internuclear axis, PZ is an internuclear axis, then PZ and PZ orbitals, they will form sigma bond, right? Then PY and PX, they can form pi bond, right? So here carbon, it has a p orbital, then there will be lateral overlapping. That is how pi bond is formed, right? So all this carbon, it can use either px. So px, 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 then this also px, then this one px, this one px, right? So all of them should use the same one, either px or py, right? PZ we cannot use. Why? It is an internuclear axis. So PZ, PZ overlapping leads to sigma bond. Here we need one pi bond, right? So this pi bond can be formed by PX, PX overlap. Then all the carbon atoms, their px will be overlapped to form pi bond. Otherwise, py, it is also right. Py, 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 py. They will form sigma bond. They are all in the same plane. What about px and py orbital? They are perpendicular to each other, right? So this is one more concept from chemical bonding chapter. So it is very important to revise a chemical bonding chapter, which are the orbitals forming sigma bond. If internuclear axis is pz, if it is px, then which of the following will form the sigma bond? Which one will form pi bond? So try to revise a chemical bonding chapter. So that is aromaticity. Here, the position of double bond, that is changed in the last class in the resonance. I have explained that why C1, C2 is forming pi bond. In the other case, C1 and C6 is forming the pi bond. So that is a difference. Or I can represent like this one. There is delocalization. Pi electrons are moving throughout the ring. So I can also represent this a benzene ring like this. So then don't remember this hydrogen. There are 6 hydrogen also present. That is aromaticity. How to identify whether a compound, organic compound, is aromatic or not? What is aroma? Aroma means smell. Okay, that's an old definition. Aroma, smell. So criteria for aromaticity. There are different conditions or criteria for a molecule or an organic compound to be aromatic. So what is the first condition? That is cyclic compound. So like our benzene, it is closed chain. So first one, cyclic compound. Then planarity, should be planar in each other. Ring should be planar. Then one more condition, that is conjugation. One more condition, that is conjugation. So conjugation we have studied in the last class. Different types of conjugation. Pi, sigma, pi, or pi, sigma, negative charge. Pi, sigma, positive charge. Pi, sigma, lone pair. Pi, sigma, free radical. Pi, sigma, heteroatom. There are different types. So there should be conjugation or alternate, double and single bond, pi, sigma, pi, right? So these are the different conditions. So if you get an organic compound, you have to check this condition. So let us check it. So can you tell me? So students, can you tell me whether this organic compound is cyclic or not? So we have to find whether it is aromatic or not. So first of all, check whether it is cyclic or not. Yes or no? Cyclic, closed chain. So you can give me the answer in the chat box. So JNV Rajkot students, JNV Varda students, JNV, I think Palakkad, class 11. Students can give me the answer in the chat box. So what is happening? So benzene ring, that is cyclic, right? What about planarity? Is that planar in nature? So we have to check the hybridization of carbon atom. So how to check the hybridization? We know, yeah, JNV Rajkot students, right? So hybridization, there is a double bond, that is sp2. This carbon, it also has double bond. So I hope you know how to find the hybridization. I have discussed in some classes, right? So here also sp2, here also sp2, here also sp2, then sp2, sp2. So sp2 in the case of carbocation, in the case of free radical, we have studied sp2 hybridization. It is planar in nature. So all this carbon in the same plane. So we can say our ring is planar in nature. So second condition, that is satisfied. What is the third condition? Conjugation should be there. That is pi, sigma, pi. So look at here. We have pi, sigma, pi. Then again, pi, sigma, pi. So throughout the ring, there is conjugation also. So 3 conditions are satisfied in the case of benzene. So we can say, okay, it's almost aromatic. There is one more condition. So we will check that condition, whether benzene is satisfying the last condition or not. Okay, so let us take one more example. So here you have to tell me, is it cyclic? First condition, is that satisfied? Yeah, it is cyclic. What about planarity? Planar. So you have to check the hybridization. This is sp2, 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 sp2. What about this plus charge? There is one hydrogen also. How to find hybridization? Number of sigma bond. There are 3 sigma bond. So it is also sp2 hybridized carbon atom. So it is a planar ring. What is positive charge? What does that mean? Positive charge. Positive charge means no electron, right? It is a vacant orbital. Positive charge, vacant orbital. So this condition is also followed. Cyclic, yeah, it is planar. Then there is pi sigma positive charge. Conjugation is also present. So it almost satisfies the condition of aromaticity. So there is, I said, there is one more condition. So we will check whether this organic compound follows that condition or not. Okay, so one more example for you. So check the condition. Is that cyclic? Yes or no? Yeah, you have to tell me whether these 3 conditions are followed or not in this organic compound. Yes or no? So cyclic ring, yeah, that is correct. Then planarity, planarity. What about this carbon? There is one hydrogen also, right? So number of sigma bond, there is 3 sigma bond. So that is also sp2. Okay, then you will say, sir, you have taught us this carbanion, they are carbanion, they are sp3 hybridized, right? So I will take the example. Suppose carbon, then hydrogen, hydrogen, one more bond, negative charge, right? So number of sigma bond, how many sigma bond? There are 3 sigma bond plus negative charge. Negative charge means it is a fully filled orbital. Fully filled means in an orbital, 2 electrons. So 2 electrons are resting there. So I can take it like a lone pair. So 3 plus 1, that is equal to 4. 4 means hybridization is sp3. In the case of carbanion, we are taking one lone pair also. So that is why the hybridization is sp3. What about this carbon with negative charge? This negative charge, look at here, pi sigma negative. Okay, pi sigma negative means conjugation. So that lone pair of electrons are involved in delocalization or in resonance. If it is participating in resonance, it can't participate in hybridization. So in this case, the carbon with negative charge, we are not considering that negative charge. Negative charge means 2 electron, lone pair. So what is the hybridization of this carbon with negative charge? Can you tell me? Only 3 sigma bond. We are not considering the negative charge. That is a rule. So in the case of carbanion, sp3. So here carbon with negative charge, that negative charge, if it is involved in resonance, it is not considered in hybridization. So only 3 sigma bond plus 0 lone pair. So sp2. So all are sp2, pi sigma negative charge. That is conjugation. That is also satisfied. So 3 conditions are satisfied. So we have to check the 4th one. So after this, we will check the 4th one. One more example for you. So can you tell me? Rajkot students are answering nicely. Great. Then what about other students? Whether this, the last one, 4th one is satisfying these 3 conditions. Yes or no? So let us check it. Cyclic. It is cyclic, of course. Then next one is planarity. So here it is sp2, sp2, then sp2. Here also sp2. So planarity, that is also satisfied. Then what about conjugation? So I can see here pi, sigma, pi, pi, sigma, pi. So that is also satisfied. All the atoms are involved in resonance. So these 3 conditions are followed or satisfied. So we have to check the next condition. So this is like an order: cyclic, planar, conjugation, then 4th one. Okay. Then let us check some more examples. So can you tell me ring or not? Yeah, of course, it is ring. Then planarity. So if you see, you will tell me that, yes, sir, of course, sp2, sp2, sp2. So it is planar in nature. So this is not the actual structure of this one. Actual structure is like this one. So like this. So actual structure is like this one. Okay, like a board, you can say. So one is above. This is also above. This is in one plane. So it is not planar. We cannot say it is planar in nature. So due to it is not planar, it is non-planar. So what is the second condition? It should be planar, then only aromatic in nature. So this is not aromatic in nature. Okay, you have to remember this example. This is known as A tunneling. You will study it later. So it is not planar, so it is not aromatic. Then what about this one? This one also you will say, yeah, ring is there. Then sp2, yeah, it is also the planarity. So it is also not planar. Here, there is one hydrogen present. Here also some hydrogen atoms, hydrogen. One hydrogen is present. This hydrogen and hydrogen, there is repulsion. So they are going out of plane, one above, one below. So I can say all these atoms are not in a single plane. Okay, so it is not planar in nature. So I can say this one and this one, it is not satisfying the condition of aromaticity. They are not aromatic. I can say they are non-aromatic. They are non-aromatic in nature. It is not aromatic. They are non-aromatic in nature. So they are non-planar due to angle strain. So this shape is known as tub shape. This is known as tub shape. Tub shape, that is a shape, not planar. Okay, is that clear? First condition, planarity. We have checked the cyclic ring, then planarity, conjugation also. Then last two examples, they are not planar, they are non-aromatic in nature. Is that clear? Yes or no? Tell me in the chat box. Is that clear to you? This definition and everything. These three conditions. JNV Rajkot students, then JNV Palakkad, then JNV Varda students. Yes or no? So these three conditions, how to identify, yeah, okay, JNV Rajkot students, great. So we have checked the condition. Next, we have to check some more conditions. There should be complete delocalization of electron throughout the ring. So let us check that one. Let us check the example. So here we have the example. Okay, then pi sigma positive charge. So pi sigma positive charge delocalization is present. Then there is complete delocalization. Why? All the atoms are involved in delocalization. So I am getting different structures. Then what about the hybridization sp2? This is also sp2. All of them are in the same plane, right? What about this one? So can you tell me? All the atoms are involved in a resonance or not? Here, here, here. So this is sp2, double bond sp2. sp2 is there. Here also sp2. Here also sp2. Here also sp2. So what about this one? There is no positive charge. There is no negative charge. There is no lone pair. So I can say this is 1, 2. How many hydrogen atom? 2 hydrogen atom. So 4. H is equal to 4. Number of sigma bond, that is 4. So hybridization, that is sp3. It is not sp2. It is not planar. What about conjugation? So pi sigma. There is no charge. There is no positive charge. There is no lone pair. There is no heteroatom. So I can say conjugation is not present. So can you tell me whether it is aromatic or non-aromatic? This one is aromatic or non-aromatic? Aromatic or non? Aromatic, just type A. Non-aromatic, just type N. So that is answer. A or N. So you have to tell me A or N. Aromatic or non-aromatic in nature. This organic compound. So you have to tell me that. So here delocalization is not completed. Why? This atom is not involved. It does not involve in resonance. So condition, one more condition, all atom forming the ring must participate in resonance. Okay, I'm waiting for the answer. You have to tell me the answer. Okay, whether it is aromatic or non-aromatic. This is a NEET question based on aromaticity. NEET 2022, there was a question. So aromatic or non-aromatic. So these are the different criteria for aromaticity. So one more condition, that is our last condition. That is, this organic compound should follow Huckel's rule. So what is this Huckel's rule or Huckel rule? So I will tell you what is Huckel rule. Participation of 4n plus 2 pi electrons in the resonance, then compound will be aromatic. If it is aromatic, it is highly stable. We know how to explain the stability of compound using inductive, hyperconjugation, resonance. Then last comes aromaticity. If it is aromatic, it is highly stable. Stability is very high. Okay. So 4n plus 2, n is integer. Okay. Suppose, let us take this example. How many 4n plus 2 pi electron, right? So how many? 4n. I'm taking n is equal to 1. Then I will get 4 plus 2, the 6 pi electrons. If 6 pi electrons are present, it is aromatic in nature. If I give it 0, n is equal to 0, I will get 2 pi electrons. If n is equal to 3, then 10 pi electrons. Then after that, 14 pi electrons. So this is a condition that compound should contain 2 pi electron, 6 pi, 10 pi, or 14 pi. Then we can call it as an aromatic compound. So let us check how many pi electrons are present in this compound. So can you tell me how many pi bonds are present in benzene? I need the answer. How many pi bonds are present in a benzene? This is our benzene, right? So how many pi bonds? So can you tell me how many pi bonds? You two friends can give the answer in the live chat section. So here one pi bond, here one pi bond, here one pi bond. So 3 pi bond are present. How many pi electrons are present? So in one pi bond, 2 electrons. So total 6 pi electrons. So 6 pi electrons means it is following Huckel rule. So it is cyclic. It is a planar. There is conjugation, pi sigma conjugation. There are 6 pi electrons. It is following Huckel's rule. So we can say this is an aromatic compound. So this is aromatic. Our benzene is aromatic in nature. If aromaticity, it is highly stable. So let us check here. So what is happening? How many pi electrons are present? So how many pi electrons? Can you tell me how many pi electrons? Here one pi bond, 2 pi bond. Then this negative charge. Negative charge means fully filled orbital. That means 2 electrons are involved in resonance. We have to check the number of pi electrons involved in resonance or delocalization. So this negative charge, that 2 electrons are also involved in resonance. So how many electrons? 6 pi electrons are present. So what about cyclic condition? Cyclic, yeah, correct. Then conjugation, pi sigma negative charge. Then what is remaining? Planarity. This is also sp2 carbon, sp2 carbon. So I can say this is also aromatic. This is also aromatic in nature. Okay, so next one more example for you. One more example for you. So this one, naphthalene I have. So check the number of pi bonds. 1, 2, 3, 4, 5. So how many pi electrons? 10 pi electrons. It is cyclic. Conjugation is present. It is planar in nature, sp2 hybridization. So I can say this is also aromatic. This is also aromatic in nature. Okay, so that is a rule. So these 3 organic compounds, they are following all the criteria to be an aromatic compound. So it is aromatic in nature. The stability is very high. Stability very high. That is very important. Aromatic compounds. Then non-aromatic. Then if it is anti-aromatic, anti, against, right? If it is anti-aromatic, stability will decrease. So if an organic compound is anti-aromatic, stability is very low. So how to identify this anti-aromatic compound? First one, cyclic, planar, conjugation. You can see all these conditions. Then fourth one, participation of foreign pi electron. What is foreign pi electron? It can be 4 pi electrons. Next one, 8 pi electrons. Next one, 12 pi electrons, etc. Then we can say it is anti-aromatic. So participation of foreign pi electron in the resonance. Then compound will be anti-aromatic and highly unstable in nature. So check here. So how many pi bonds? There are 2 pi bonds present. What about positive charge? Positive charge means no electrons. It is a vacant orbital. So 2 pi bonds means 2 into 2. 4 pi electrons are present. So it is following 4 and pi rule. 4 and pi electrons. 4 into 1 into pi. 4 pi, right? So 4 pi. So this is anti-aromatic. This is anti-aromatic. If it is anti-aromatic, stability is very low. If it is aromatic, stability is very high. If it is non-aromatic, it is in between. Stability is in between. So one more example. So can you tell me how many pi electrons are present in this organic compound? JNV Rajkot students, other students. How many pi electrons? So check the number of pi bonds. There are 2 pi bonds present. So 4 pi electrons are present here. So what about, yeah, JNV Rajkot students, 4, right? So what about other condition? First condition, it is a cyclic, that is satisfied. It is planar, sp2. Conjugation is present, sp2, sp2. So pi sigma, pi conjugation is present. 3 conditions are followed. And check the 4th condition, If it is following 4n plus 2 pi rule, then that is aromatic. If it has 4n pi electron, then it is anti-aromatic. Anti-aromatic stability decreases. So this is also this is also anti-aromatic. So these are the different rules to identify whether a compound is aromatic or not, whether it is more stable or less stable. Okay, so note all these points. Then after that, I'm going to give you a question for you. Very simple question. Based on the things that we have studied, you can easily answer the question. So get ready, get ready. So take the pen and paper. You have to check all the conditions. So identify these, whether they are aromatic, anti-aromatic, or non-aromatic. So first one you have to tell me. So fast, I need the answers in the chat box from all the schools, all the JNBs. First one, we have studied that whether it is aromatic, anti-aromatic, or non-aromatic. So we are going to practice it. Okay. So you have to give me the answer. If it is wrong, okay, no, fine. Okay, it's fine. So find the answer. Find the answer. So find the answer for this one. So cyclic, yeah, that is correct. Then after that, you have to check planar or not. Yeah, sp2 hybridized. Yeah, it is a planar. Conjugation, pi, a sigma negative charge. Conjugation is present. Then I can call it as there is 5-member ring. How to remember? This is 5 minus 5-member ring, then with a minus charge. 5 minus, you can remember like that, 5 minus. So aromatic or not? You have to tell me aromatic or not. Then second one, so pi electron 2, 4, 6, 8, 8 pi electron. Yeah, cyclic, conjugation is there. Aromatic or anti-aromatic. Then this one, there is oxygen more electronegative, it will take the electrons. So I will get a positive charge here. So 2, 4, 6. So there are 6 pi electrons, 6 pi electron. I'm helping you, 6 pi electron here. So whether it is aromatic or not. Then here. So there is an sp3 hybridized carbon atom, whether it is aromatic, anti-aromatic, or non-aromatic. So you have to follow the criteria. Okay, I'm not getting the answer. First one, whether it is aromatic. Then last one here, it is 3 plus. It is 3 plus. Okay, so 3 plus, which are aromatic, which are anti-aromatic, which are non-aromatic. So 3 plus means here it is sp2 conjugation. It is cyclic. Yeah, it is satisfying the condition. So I'm not getting the answer. So I will show you the correct answer. So first one, 6 pi electron, it is following the criteria. So I can say it is aromatic in nature. What about the second one? 2, 4, 6, negative charge, 2 electrons. So 8 pi electrons are present. 8 pi electrons means it is anti-aromatic in nature. So next one, I have explained this. Oxygen, more electronegative, pi electrons, it is going there. So positive charge on the carbon atom. So that is sp2. Then count the number of pi bonds in the ring, okay? Only in the ring you have to consider the pi electrons participating in resonance. So this is participating in resonance. This is participating in resonance. This one is also involved. So what is the correct answer? 2, 4, 6. There are 6 pi electrons. So it is also dash in nature. It is also aromatic. It is also aromatic in nature. So what about the next one? sp3. So it is ring. There is ring. Okay, that is cyclic ring is there. What is the second condition? Planar. No, it is not planar. It sp3 carbon is present. So it is not aromatic. It is not anti-aromatic. So we can say it is non-aromatic. It is non-aromatic in nature. Then last one, ring is the conjugation. Pi sigma positive charge is there. Then it is planar, sp2 hybridized carbon atom. Then how many pi electrons? 1 pi bond, 2 pi electron. It is following Huckel rule. So I can say it is aromatic in nature. Is that clear to you? This question, is that clear to you? This question, how to find it? Number of pi electrons. The negative charge means 2 electron. If it is involved in resonance, you have to count that. Then if it is clear, we have to do a previous year question. Yes or no? You can give me the answer in the chat box. I know you are attending the class carefully with 100% focus. You won't be able to walk to the spot and type it in the laptop. Rajkot students, maybe you are able to type it. If it is clear, let me know. Then only we can do a previous year question. So we have to do a previous year question just after this. Yes or no? If it is yes, we have to do the yeah, JNV Rajkot students, great, great, great. So if it is clear, we have to do this a previous year question. So what is the trick I have mentioned? If it is 3 plus, if it is 3 plus aromatic, 5 minus aromatic, 7 plus aromatic. So all of these are aromatic in nature, aromatic. So 3 plus, 5 minus, 7 plus. So ring is there, then plus charge. Also there should be negative, sorry, also there should be pi bond, okay? 4n plus 2 pi electron. So which is the correct answer? Yeah, correct. JNV Rajkot students are again scoring. So this is our 5 minus. We know they follow all the conditions of aromaticity. So 3 plus, that is also correct. Then here it is 1, 2, 3, 4, 5, 6, 7. Okay, this is 7 plus. What about this one? There is sp3 carbon atom, not sp2 carbon atom. If sp2, then it is planar. Then here, there is no conjugation present. So it is not aromatic. It is not anti-aromatic. So we can say it is not at all an aromatic compound. So this is our fourth one is the correct answer. So this is from NEET 2022. So latest NEET exam, NEET 2022. So we know how to solve the questions related to aromaticity. Okay. So in the next class, we will solve more number of questions if possible. So that is all about aromaticity. There are different concepts, but due to the limitation of time, we are studying only the important points, how to identify, how to score good marks in our examination. So if that is clear, so we have to go to the last topic, one of the last topic. So in this topic, from this topic, you will get questions, mostly this direct question. We have studied without calculation, without doing anything, we can take the answer. Okay. And also this purification and the qualitative analysis. Qualitative analysis means suppose carbon, hydrogen, sulfur, etc. Some elements are present. We have to identify whether it is present or not. Qualitative. What is quantitative? We have to estimate the percentage. Suppose carbon is present. What is the percentage of carbon present in that organic compound? That is quantitative. So first we will study about qualitative analysis and how to purify these organic compounds. If some impurity is present. I think this purification we have studied in 8th or 9th class. A chapter, I think, matter in our surrounding or something like that. 8th or 9th, mostly. I don't remember exactly. So in that chapter, you have studied sublimation, crystallization, distillation, these things. Yes or no? Before COVID. Okay, it is before COVID. Otherwise, JNV students, Anna. So you will say, sir, COVID batch. We have not studied that. It is deleted portion. Okay, before COVID. 9th standard means, yeah, it is before COVID. You have studied that things. So let us revise all those topics, purification and qualitative analysis, whether a carbon, sulfur, etc. is present in a compound or not. How to check that? There are different methods. Based on this, direct questions will be there in a JEE and NEET. So first, let us study about purification. So purification, there are different methods, n number of methods. So I have taken some of the methods which are important for you. So first we will study about sublimation, second crystallization, third one is distillation. So can you tell me what is a sublimation? Anyone in the chat box? So what do you mean by this sublimation? We have studied sublimation. I know that. Okay. It's a very simple question, right? Sublimation means what? So what is sublimation? Anyone? Sublimation means something is getting converted into something. So what is that something and something? So sublimation, you have to tell me the answer. So method of purification, yeah, JNV Rajkot students, correct. So method of purification of organic compound. So let us study about this one. Purification of organic compounds. There are so many purification techniques. So which method we have to use? How to select that? So it is based on nature of the organic compound and the impurity present in that. So based on the nature of the organic compound and the nature of the impurity, we will select which purification method to be used. So let us study about that in detail. So we will study about sublimation, crystallization, distillation, and chromatography. From this distillation and chromatography, more number of questions are asked in JEE. Sublimation and crystallization, you can almost leave. Okay, we can keep them aside. So let us study about distillation and chromatography in detail. So what is sublimation? Already JNV Rajkot students has given me the correct answer. It is used to separate sublime compounds from non-sublime impurities. So organic compound, it will show sublimation. For example, only for example, I'm taking ammonium chloride. This example you have studied in 8th or 9th. So ammonium chloride is there. Then there is burner. Then China dish. In the China dish, there is ammonium chloride. There is a funnel. What is this inverted funnel? Okay, I'm inverting. The position is changed. Inverted funnel, and above that there is a cotton flip, right? Then I'm heating our ammonium chloride. So solid to gas. So it will go. So vapors of ammonium chloride are formed. Then it will reach to the sides of our inverted funnel. Then finally, solidified ammonium chloride is formed. So we can separate it from easily. What about impurity? Impurity will be left behind. So this is one technique, sublimation. So ammonium chloride, it is showing sublimation. What about naphthalene? So do you know naphthalene? What is the use of naphthalene? In your houses also, you may have used naphthalene bowls. So naphthalene is there. So what is that? The use of naphthalene in your houses. Do you know that naphthalene bowls? So naphthalene also, naphthalene plus impurity. We can separate the organic compound naphthalene from impurities by using sublimation technique. That is another application. So ammonium chloride, naphthalene, anthracene, etc. We can use very simple method. We can leave that. You know, you have studied that already, right? Next one. So what is next? Crystallization. This crystallization in your degree classes, if you're joining for BSc chemistry or BSc physics, you have to do chemistry practical. So next year also in 12th also you have to do that. What is this crystallization? I have done this crystallization during my degree, BSc chemistry that time. MSc also we have done some of the experiments. So when will we use crystallization? So it is based on solubility of the compound and the impurities in a suitable solvent. So let us check the example. Let us check it. So I'm taking a solvent. I have a impure organic compound. So some impurities are present there. It is sparingly soluble at leave that in the examination they won't ask the process. What is the step 1, step 2, etc. Then in the next step, I'm heating that, I'm evaporating that. There is solvent also present. So solvent will be going up, evaporation will take place. Then I will get a concentrated solution. It is highly concentrated. Then what is the next step? I am allowing this solution to get cooled. So I'm cooling the solution. So during that time, okay, so we have the organic compound. The crystals of organic compound will be formed, right? So on cooling the solution, pure compound, pure organic compound crystallizes out. Then our impurity, it is also there, right? Then we have to separate our pure crystals from this solvent. How to do that? We can use a filter paper. So using filtration, there are different kind of filtration. So using filtration, we can remove this impurity, solvent, and our pure organic compound. So I'm using a filter paper. I'm pouring the solution. Crystals are present. So crystals will be staying there. Solvent will go through the filter paper. So I will get the crystals. Then these crystals will be wet. So we have to dry these crystals. How to do that? So take 2 filter paper. Then our crystals are present. Take 1 more filter paper. Press that. So you have to press that. Then we can dry our crystals form. So crystallization means we are taking an impure compound. There is a solvent also. We are heating that solution. Then majority of the solvent will be gone. I will get a concentrated solution. Then after that, allow the solution to cool. Okay, it will get cool. Then our pure organic compound will be transformed as crystals. Then we have to separate these crystals using a filter paper. We can separate these crystals. Then how to dry the crystals? Take a filter paper, 1 more, press it. So we can dry our crystals. That is known as crystallization. So sublimation, crystallization, not that much important. Just you have to understand, okay, these are the purification techniques based on the solubility of the compound and the impurity. So is that clear to you, crystallization? If it is clear, so we have to study the important one. This distillation also you have studied already in different chapters. So distillation, One is simple distillation. It is very simple. Second one, somewhat complex. Fractional distillation. Fractionating column is used. What is third one? Distillation under reduced pressure. One previous year question was asked from distillation under reduced pressure. The last one, that is steam distillation. Okay, so we are studying about distillation. We are studying about purification of different organic compound. Based on the nature of the organic compound, nature of impurity, we have to select the purification technique. So here we are studying about distillation, which are the different types of distillation: simple distillation, fractional distillation, distillation under reduced pressure, the last one, steam distillation. Okay, we have to go through all these things. So next one, we have to study about simple distillation in detail. So it is very important to remember the examples. So which are the organic compounds that we can separate using simple distillation? In NCERT itself, it is given example. We have to study those examples. So simple distillation means, so you can tell me, simple distillation means what? So which are the compounds that can be separated using simple distillation? Okay, to separate volatile liquids from non-volatile, volatile. Okay, then impurities or liquids having sufficient difference in their boiling point, or I can say I have two components and they have large difference in their boiling point, then I can separate them using simple distillation. So what is happening in simple distillation? Example, this example is very, very important. Simple distillation, we have chloroform 334, aniline. You know how to write the structure of aniline. So 457 Kelvin, there is large difference in their boiling point. So we can separate them using simple distillation. So an example for you, that is chloroform and aniline. Then what is the setup? What about the setup? So here we have different apparatus, then thermometer, flask is there. Then we are heating the solution, condenser is present, then vapors are formed, then boiling. So vapors are formed, it will pass through the condenser. Then finally there is a conical flask. In that flask, we are collecting the liquid, right? So what is happening? Chloroform and aniline. So one with lower boiling point. So boiling point low. So we have to give less amount of heat. So it will get vaporized. So vapors are formed. So the component having lower boiling point, the vapors are formed first. It will pass through the condenser. And finally, in a conical flask, we will get the liquid. Then after some time, the next one. So chloroform and aniline, that is an example for simple distillation. Is that clear? Simple distillation. Only you have to remember the example. So next one is fractional distillation. So fractional distillation is used for the separation of dash and dash. So first case, you have to tell me the answer. Fractional distillation is used for. So what is the condition? In the simple distillation, there should be large difference in their boiling point. In fractional distillation, if the components has very small difference in their boiling point, then we will use fractional distillation. So what is the point? When difference in boiling points of two liquids is not much or only small difference in their boiling point. So we are taking again our apparatus are there, then fractionating column is there. Fractionating column, there are different types of fractionating column. You can use glass beads to fill this fractionating column. Why? So it is increasing the surface area. Then thermometer, then condenser is there. Then finally, we will get the liquid, distilled liquid in our conical flask. Then two liquids, right? One has boiling point high, one has boiling point low. So vapors of the liquid with higher boiling point condenses before the vapors of the liquid with lower boiling point. So that is happening here. So we can separate them because of the presence of fractionating column. So point is the difference in boiling point, that is not that much. So that is about fractional distillation. So I'm covering it fastly. Why? You have already studied the point. Simple distillation, what is that? Fractional distillation, what is that? Okay. The next one, application of fractional distillation. So this one, in hydrocarbon, you will study about this one, fractional distillation application. So we have crude oil. There are different components present in crude oil. their boiling point difference that is very small. So we have to separate these different components. How to do that? We can use fractional distillation. So technological applications of fractional distillation is to separate different fractions of crude oil in petroleum industry. So you have to remember fractional distillation that is used in petroleum industry to separate different components present in crude oil. So we can see different components present here. There are different components we have to separate. For example, petrol, diesel, we will study about that. So we have to separate these components with very low difference in their boiling point. We can use fractional distillation. So that's about simple distillation and fractional distillation. So what is next? That is distillation under reduced pressure. Reduced pressure means we are decreasing the pressure, right? So when will we use this one? It is used to purify liquids having very high boiling point. So boiling point is very high. So look at the apparatus here. So here I have a vacuum pump. Why vacuum pump? So reduce pressure. I'm decreasing the pressure. So our liquid is present here. The boiling point of that liquid is very high. Or I can say one more condition. This liquid, before reaching its boiling point, it will undergo decomposition. It will undergo decomposition before reaching the boiling point. So we have to reduce that boiling point, right? So what is this boiling point? So boiling point means it is a temperature at which vapor pressure, that is vapors are formed, pressure exerted by the vapor, simply vapor pressure. So boiling point means it is a temperature at which vapor pressure of the liquid that is equal to atmospheric pressure. Vapor pressure should be equal to atmospheric pressure. So I want to reduce the boiling point, right? So here what is happening? Suppose normally this liquid is boiling at 400 Kelvin, right? So the point is before reaching the boiling point, this liquid will be decomposing. Okay, so 400 Kelvin, that is a boiling point at 1 atm pressure, atmospheric pressure, 1 atm normally. So here I'm using a vacuum pump. So I am reducing the external pressure. Suppose here I have 0.5 atm. So 0.5 atm, that is the external pressure. So boiling point, vapor pressure, that is equal to external pressure. So pressure is decreasing. So I can say boiling point, this will boil at 300 Kelvin. If I allow that to reach up to 400 Kelvin, before reaching 400, it will be decomposed. So I'm reducing the boiling point. So how? I'm using a vacuum pump. So under reduced pressure, 1 atm to 0.5, 400 to 300 Kelvin. So it is happening. I can separate that. So one more point here, a liquid boils at a temperature below its vapor pressure. By reducing the pressure, we are decreasing the pressure here. Okay. So that is all about distillation under reduced pressure. What is the extra fitting? There is a vacuum pump. Why vacuum pump? It is reducing the pressure. Then important point, what is boiling point? It is a temperature at which a vapor pressure that is equal to the atmospheric pressure. So by this method also, we can separate the different compounds. That is distillation under reduced pressure. For which organic compound we are using this? Liquids. Purify liquids having very high boiling point, and before reaching their boiling point, if they are decomposing, then we can use this distillation under reduced pressure. So it is somewhat different, but still you will get some kind of idea about this reduced pressure. What is that? So distillation under a reduced pressure. So we have studied simple, fractional, distillation under a reduced pressure. So what is the application? So there are different kinds of application. So can you tell me what is this image? I think it is pretty visible to you. Application of distillation under reduced pressure. So application is in soap industry, glycerol. So what is the structure of glycerol? This is our glycerol, 3OH. So glycerol can be separated by using this method. So what is this method? So distillation under reduced pressure, right? So this is an application of distillation under reduced pressure. So what you have to study? So if you get the idea about the process, it's well and good. Or otherwise, you have to study the example. So generally in NEET, JEE, etc., they will ask the example. They will give different example. Then they will ask you, so which purification technique you can use to separate this organic compound. So this is the application of distillation under a reduced pressure. Then everyone must give me the correct answer for this question. Everyone, Rajkot students, Varda students, JNVP, class 11. So what is the correct answer? This is from JE. JE means question. So glycerol is separated in soap industry by. So which is the correct answer for this question? Yeah, JNV Rajkot students, yeah, correct. So fractional distillation we have studied. Differential extraction we will study. Steam distillation we will study about that. Distillation under a reduced pressure. So distillation under reduced pressure, that is the correct answer for a JE mains question. So in JE also, simple questions will be asked. It's not about JE means it's very high, it is very tough. So they will also ask simple questions. So you have to study this portion also. So main thing is you have to study the examples for different purification techniques. So glycerol, then distillation under reduced pressure. We are reducing the pressure. So it is used to purify the liquids having high boiling point, and before reaching the boiling point, they will undergo decomposition. So we are reducing the pressure and separating that one, right? So next, one more distillation that is remaining, right? So steam distillation. What is steam? Steam, water. So to separate substances which are steam volatile and are immiscible with water, okay, they are not mixing with water. So steam volatile and are immiscible with water. So again, so what is happening here? So this is a setup for you, okay. So this is our compound to be distilled. This is a compound to be distilled. What is boiling point? Vapor pressure should be equal to atmospheric pressure. So this liquid, it is not forming that much vapors. It is forming only very less amount of vapors, right? So boiling point, vapor pressure is equal to atmospheric pressure. So this liquid is asking the help of water. So water is present. So water, it is volatile. It will form the vapors very easily. So water, we are heating that. Then vapors are coming, vapors are coming, vapors are coming. So from this point, our liquid, the vapors of this liquid is also forming. They are going through this condenser. And finally, so what is happening? We are getting water as well as distilled liquid. They are immiscible in nature. So we can easily separate them. So why we are using water? Steam distillation. So liquid boils when pressure, vapor pressure, that is equal to atmospheric pressure. So this is P is our atmospheric pressure. So P1, that is a vapor pressure due to organic liquid. So vapors created by this organic liquid, that is very low. So boiling, it won't take place. So we are taking the help of our water. So water, vapors of water, it is forming. Vapors due to organic liquid, that is also forming. So total pressure, that is P1 plus P2, that is equal to atmospheric pressure. So if it is equal to vapor pressure is equal to atmospheric pressure, then boiling will take place. So we are taking the help of water. That is why it is known as steam distillation. So P is atmospheric pressure. P1 is a vapor pressure due to organic liquid. P2 is a vapor pressure due to water. So vapors are formed. It will condense. Then our water and distilled liquid is formed. Then how to separate? They are immiscible like oil and water. So we can easily separate this water and distilled liquid. Then if some impurities are present, it will be left in the beaker itself. This is our steam distillation. That is with the help of water, we are purifying the organic compound in the liquid state. So the point is pressure, atmospheric pressure, that is equal to the vapor pressure due to our organic liquid plus vapor pressure due to our water. So that is happening here. So these are the 4 different kinds of distillation techniques. Is that clear to you? Different distillation techniques? Yes or no? Different distillation techniques. Is that clear to you? JNV Rajkot, JNV Palakkad, I think. Is that clear to you? These distillation techniques. You have to study the examples, generally examples. So in NCERT, it is given, you have to go through NCERT textbook. Steam distillation. Okay, Rajkot students, well and good. So we will go for next purification technique. We will just start chromatography. From chromatography also, questions are asked. So chromatography, what is that? So chromatography in Greek, chroma means color. Okay, so chromatography, chroma means in Greek, it is color. This technique, chromatography, it was first used to separate colored substances present in plants. In plants, there are so many compounds. Some colored substances are there. To separate those colored substances, this chromatography was first used. So you will have a doubt, sir, can we separate the substances without color also? Yes, of course. Why chromatography? It was first used to separate the colored substances. That is why the name. We can also separate other components also. So what is happening here? In chromatography, there are two phases. One is stationary phase. Stationary, like me. I'm sitting here. I'm at rest. That is a stationary. So that is our stationary phase. So it can be mixture of substances. It can be solid or liquid, etc. So that is our stationary phase. Then there is one more phase in chromatography. One is stationary, one is at rest. What about the next one? So they are mobile phase. So pure or mixture of solvent or gas. That is our mobile phase. Mobile phase, they are moving. So I will keep the stationary phase here. Then I will pour some mobile phase over that. So this mobile phase will be moving over our stationary phase. Then what are the points related to chromatography? So components of mixture get separated from one another. So I have a mixture. In that mixture, there are different kinds of components. Component A, B, C, D, etc. So I have to separate each and every component present in that mixture. For that, I can use chromatography. So technique used is a chromatography. There are different types of chromatography. So first one, adsorption chromatography. Second one is partition chromatography. AP, not Andhra Pradesh, that is AP. So adsorption chromatography and partition chromatography. These are two different kinds of chromatography. In adsorption chromatography itself, there is ATC. I can write ATC. This is thin layer chromatography. This is column chromatography. C means column chromatography. Then in partition chromatography, I can say there is paper chromatography. So partition chromatography or paper chromatography. In adsorption chromatography, there is thin layer chromatography as well as column chromatography. These are the different kinds of chromatographic techniques present in our work. So our first one, adsorption chromatography. So do you know what is this adsorption? So what do you mean by this adsorption? So this is based on the fact that different compounds are adsorbed on the surface of adsorbent to different degree. So what is this adsorption? What is that phenomena adsorption means? So do you know what is this adsorption? You might have seen this white colored powder covered in a plastic paper, then in your electronic devices, in your bag, etc. So that is our silica gel. So what is the role of silica gel in electronic devices? They will adsorb, not absorb. It is adsorb. They will adsorb moisture. Adsorb moisture present in electronic devices. Silica gel. There is alumina gel also. So that is a substance which is working, which is absorbing the moisture. So that is known as adsorbent. Adsorbent. Then what about water? So water is coming and getting adsorbed. That is known as adsorbate. So moisture or water, that is known as adsorbate. Okay, bait, it is coming and getting adsorbed. Then adsorbent, it is providing the surface. So water molecules are coming and getting adsorbed on the surface of silica gel. So silica gel is known as adsorbent. So what is absorption? Suppose you take a sponge and water. Then sponge and water, this water will get into the sponge. That is absorption. Adsorption means adsorption. Here it is adsorption chromatography. So moisture is coming. It is not going into the silica gel. It is accumulating at the surface of the silica gel. So I can call this adsorption as a surface phenomenon. It is a surface phenomenon. Adsorption is a surface phenomenon, not absorption. Absorption is a bulk phenomenon. The water is going into the sponge. Here, this moisture is accumulated at the surface. So here adsorbent, it is silica gel or alumina gel. Then again, our adsorption chromatography it is divided into two categories. So which are the two categories we have studied? This is also a previous year question. So first one's column chromatography. So what is second one? That is thin layer chromatography or TLC, thin layer. What is this thin layer? What is this column? So cylindrical column is used. In column chromatography, cylindrical column is used. So that is why it is known as column chromatography. In thin layer chromatography, what is used? there is a thin layer of adsorbent, thin layer of adsorbent on glass surface, That is why it is known as thin layer chromatography. Okay, so that is about adsorption chromatography. There are two types, column chromatography as well as thin layer chromatography. So in the next class, we will study about this column chromatography and what is this adsorption chromatography, etc. So that's all about today's class. These questions, we will do it in the next class. So you can take it as a homework question. This neat question. Paper chromatography is an example of. You can give me the answer now or later. No issues for that. NEET 2020 question. Paper chromatography is an example. In adsorption chromatography, Andhra Pradesh, AP. Then below that, ATC, thin layer chromatography, column chromatography. It's an example for adsorption, right? So paper chromatography, it is an example for which type of chromatographic technique. So do you know the answer? So paper chromatography, I have mentioned that. So this is asking NEET 2020. Direct questions are asked from this portion. Direct question. Yeah, JNV Rajkot students, you are doing a great job. So paper chromatography, that is an example for partition chromatography, then adsorption in that thin layer and column. So great, we will keep it here. So in the next class, we will study about what is this column chromatography. So what is this thin layer chromatography? What is this paper chromatography, etc. in the next class. So we have to just listen to the class. So make the notes if possible, then revise through your NCERT. And chemical bonding chapter also, how to find hybridization, you have to revise them. So it is time to revise the things. Okay, then students, we will meet you in the next class. We will solve more number of previous year questions in the next class. Okay, then bye. We will see you in the next class. Bye bye. Okay, JNV Palakkad students, bye. So I'm ending the meeting for all of you.